What's up mga taong GRESA? Andito na naman po ako para mag-discuss sa inyo ng tungkol sa unang-unang letra na matatagpuan natin sa GRESA, which is yung letter G. So nasa given pa rin po tayo, and this time given part 3 of 13. 10 to go and we're done. So ngayong araw, ang pag-uusapan naman natin is yung mga klase ng physical quantity. So pwedeng maklasify sila as fundamental or derived, pwede rin namang scalar or vector. Next time, pinakita ko sa inyo itong characteristics of physical quantities. And ito yung mga characteristics na na-discuss nung nakaraang video. Physical quantity is a property of a material or system that can be quantified by measurement. It is something that can be expressed as the combination of a magnitude and a unit. And lastly, physical quantity is represented by symbols, and in physics, ang ginagamit natin usually ay either English alphabet or Greek letters. So this time naman, pag-uusapan natin yung characteristic ng physical quantity wherein pwede natin siyang maklasify as either fundamental and derived. And bakit mahalaga na alam natin yan? At saka yung classification na scalar at saka vector. So unahin muna natin yung classified as fundamental or derived. Okay? Ayan. So, fundamental versus derived, pag sinabi nating fundamental, in the sense of it, ito yung mga foundation, pinakaunang dapat mong malaman, basic, kumbaga. Ito ay also tinatawag na base quantities. Meron tayong 7 considered sa buong science itself, no? Meron tayong mass, time, length, temperature, amount of substance, electric current, and luminous intensity. Sila ay yung 7. At kaya sila tinawag na fundamental kasi sa kanila actually nade-derive yung other quantities na meron tayo sa physical sciences. So that includes chemistry at syempre kasama ang physics. So paano ba nade-derive yung derived quantities galing mismo sa fundamental quantities? Ayan. So meron tayong iba't ibang means para magawa yun, no? Yung una is by multiplying 2 or more similar or different base quantities. O ulitin ko ha, pag sinabi nating fundamental, pareho lang yun ng base quantities. Sa physics, mahalaga din yung vocabulary natin. Alam natin kung ano yung mga salita na synonymous sa isa't isa. So hindi lang siya basta sa English, no? Useful din siya sa physics at saka sa iba pang mga sciences. So tingnan natin yung mga example dito, no? So ito ay similar or same base quantities na minultiply mo. Dalawa lang din sila. Ano yung magiging resulta kapag minultiply mo yung length at saka yung length? The result is the derived quantity we call as area. So mga examples lang to, marami pang nagkalat at marami pa tayong mai-encounter in the future. Isa pa, ayan, so hindi lang 2 beses mo pwedeng i-multiply yung similar base quantity na length. So pwedeng length times length times length. And this one will result to the derived quantity called volume. Alam mo, di ba, hindi naman ganyan yung area. Di ba yung area, length times width, o kaya naman length times height. Tapos kapag volume, di ba ma'am, length times width times height. Actually, sa ano nga lang yun sa yung kaninang sinabing length times width, sa rectangular area lang yun. Tapos yung itong length times length or length times width times height, para lang naman yun sa volume of prism, no, na rectangular prism specifically, no? But basically kasi, galing sa fundamental quantities, length at saka length talaga, yung pinag-multiply mo doon. Nag-iiba-iba lang ng tawag para alam mo kung anong part iyon nung shape or nung 3-dimensional object na kino-compute mo. No? More of that in the future. Another thing is the electric current times time. Pag minultiply mo yung electric current at saka time, the result will be charge. Ayan. Okay. So ito yung mga examples natin for forming derived quantities by multiplying two or more similar or different base quantities. So meron tayong dalawa na magkapareho, tatlo, pinag-multiply, magkakapareho, at pwede rin namang dalawa o higit pa actually na magkaibang base quantities. Okay? What's the second method? No, the second method could be by dividing two or more different base quantities. So ano yung mga example natin para dito? We can actually divide 1 by time. Okay? So i-consider na natin yung na two or more. No? Ayan. So pag dinivide mo yung 1 by time, or actually ni-reciprocal mo yung time, you will be able to get the derived quantity we call as frequency. And then, if we divide naman length by time, ang mga base quantities yon, no? Na ito naman, magkaiba naman, no? And then, it's gonna be, the result can be speed. Ayan. And then, next method is, gagawin mo pareho. Pwedeng, at the same time, you multiply and divide two or more different base quantities. Please take note lang, no, na kapag magde-divide ka ng base quantities, hindi siya pwedeng divide two or more na similar or same quantities kasi magka-cancel out sila. No? So dito, sa third method, it's gonna be multiply or divide two or more different base quantities. But actually, it could be a combination of the two. You multiply same quantities, pwede rin yun, no? More examples on that. I'm just showing you how they are formed, no? Ayan. So first example is force. Force is a derived quantity from mass, length, and time squared. Ayan. Diba sabi ko, ayan, may mass, length, at saka time, di ba magkakaiba sila, tapos tatlo sila, no? And then pwede rin na yung same quantity, i-multiply mo sa isa't isa, just like time. If you square time, it means you multiply it by itself, di ba? Ayan. So that's the first example. Second example is work. And work is a combination of this base quantities. We have mass, length, time squared, and another length. Actually, this form is due to their equations, which we will discuss in the future. Kaya baka nagtataka kayo, bakit nga parehong may length, dala-dalawa yung length, bakit hindi na lang sila ma-cancel out? Soon you will know why we don't cancel them out even if we could, o kaya naman hindi natin pinag-multiply even if we could. Ayan, so those are the examples, the methods of us being able to come up with the derived quantities. Basta lagi mong tandaan yung fundamental, 7 lang yun, at paghahalu-haluin lang natin, mix and match, so that we could get the derived quantity. Now this time, let's focus on a scalar and vector. Ayan. So, differentiate natin sila sa isa't isa. And let's start by discussing what scalar quantity is. Pag sinabing scalar, hindi kailangan ng direction. So, ang kailangan lang niya para makapag-describe is yung magnitude. Tandaan natin pag sinabing magnitude, this is a number together with a unit. So, kada scalar quantity, madedescribe lang siya by the numerical value at saka yung unit. Siyempre, wag natin kakalimutan yung unit, no? Usually, but not necessarily, positive siya palagi. Pero syempre, may exemptions to the rule. Makikita niyo marami talagang mga bagay na pasaway dito sa physics. Lalo na sa pagsusolve, may lalabas at lalabas na exemptions to the rule. Ayan, laging nandun yun. Hindi siya mawawala. Okay, so later we will see how work is actually an exemption to this. Actually, meron pang iba, like charges, may positive, negative, no? And other things, ayan, soon. Okay, and it can be manipulated by ordinary laws of algebra. Meaning, kapag mag-multiply ka ng scalar tsaka scalar, walang komplikadong mathematics. You just multiply. Pag nag-add ka ng scalar tsaka scalar, walang complicated math. Plus lang, ganun lang siya. Plus mo yung magnitude, dapat pareho sila ng unit, tapos okay na. Ganun lang siya kasimple, no? Ano yung mga examples nito? We have volume, with a specific example of 1 cubic centimeter. We also have density with a specific example na 2 kilogram per cubic meter. And then we have speed, example 3 meter per second. We have energy, which is 4 joules. Excuse me po. Mass, with example 5 kilograms. And then time, which is having an example of 6 minutes. Ganyan siya kasimple, walang negative. Usually except for the exemptions to the rule. Usually wala siyang positive, walang negative, number lang, tsaka unit. Ayan. So kung makikita mo dito, halo na to, no? So yung scalar quantities, pwede siyang maging fundamental at pwede rin naman siyang maging derived. Ayan. And then next is si vector. Ang medyo pinagkaiba lang naman nila, si vector, maarte siya, no? Opo. Kailangan niya ng direksyon. Oo, parang mamamatay siya. Hindi siya mag-exist kung walang direksyon. Yun yung kanyang major characteristic, major difference sa scalar. It can be positive or negative depending on direction. So yung pag may nakitang positive and negative, it actually indicates direction if the quantity is a vector 1. And then graphically represented by an arrow whose direction is the same as that of the quantity and whose length is proportional to the quantity's magnitude. Ayan. Siyempre, dahil may direction, ano ba usually yung ginagamit natin para malaman natin yung direksyon kung saan papunta, di ba, yung arrow. Kaya naman, nire-represent natin graphically ang mga vectors as arrows. Usually, proportionate dapat kung gaano kahaba yung arrow mo. Dapat naka-scale siya, pero most of the time, kapag rough sketch lang naman, wag mo nang pahirapan yung sarili mo. Kasi ang pinaka-importante talaga dito, malaman mo yung direction. Okay? Hindi naman kailangan perfect na naka-scale yung arrows mo. Ayan. Here are some examples, no? We have what we call as displacement. The specific example is 1 kilometer. That's the magnitude, the numerical value in the unit. East, okay? Yung direction, which is actually equal to positive 1 kilometer. So here's another rule of thumb, no? Kapag magsusulat ka ng vector quantities as you're given. Sa problem mismo, sa problem solving, babanggitin kung anong direction niya. Halimbawa nga, sa problem, ang sasabihin sa'yo, the object is going 1 kilometers east. Pupunta daw siya ng east, tapos ang ito-travel niya ay 1 kilometer. Pag isusulat mo na siya sa given, it is better if you transform the direction into the sign. Ayan. So later on, mga didiscuss din natin paano malalaman kung positive, paano malalaman kung negative yung direction ng ating vector, no? More of that. Okay, next, we have velocity, and the specific example is 2 meter per second, wherein, again, 2 is the numerical value, and meter per second is the unit, and then the direction is W, which is shortened as west. And then it can be transformed, pag isusulat mo na siya as given, na negative sign. Ayan. So, equal lang si 2 meter per second west sa negative 2 meters per second. Next example is force, which is having a specific example of 3 newtons south. Ayan. So, yung 3, that's the numerical value rather, and then N is the Newton, which is the unit of force. So kapag isusulat natin siya ulit na given, gagawin lang natin negative kasi south is actually a negative direction. In the next example, we have momentum. We have 4 kilogram dot meter per second, which is actually the magnitude, pinaghalong number and unit. And then the direction is north. Ayan, medyo nakakalito, no? Kasi kanina, Newton yung N. Tapos, ngayon naman, yung N ay north. So, you have to be careful, no? Kapag isinusulat to. Pwede mo rin naman kumpletuhin kung medyo nalilito ka, okay? Kasi pwede rin yung dito sa force, 3 and N. So, baka malito ka, no? Ayan. Or take note of the comma. Kasi yung comma, yun yung naghihiwalay sa magnitude at saka sa direction. And then, ayan, let's continue. Instead of having the north direction in the given, we just write the positive sign, which is indicating the direction, no? And then lastly, we have torque, which has kind of a different direction orientation. Kasi sa mga paikot na bagay, gumagana yung torque, no? So we have here 5 Newton meter. So pwede rin Newton dot meter. Pwede mo siyang basahin that way. This one is the magnitude. And then the direction is CW or clockwise. Ayan. So sa study natin ng torque, yung clockwise is negative, tapos yung counterclockwise ay positive. Hence, instead of writing CW sa given, ang ilalagay natin is yung negative sign, which is equivalent to the direction. Okay? So pwede isulat negative 5 Newton meter. Ayun lang muna tayo for today. We have been able to characterize the physical quantities according to all of their major characteristics. No? So next time, itutuloy natin ang ating pagdidiscuss about the given. Mahaba-habang discussion pa ito, but I hope you would still stay with me and watch out for the next one. Yun lang muna. Bye! Like and subscribe kung gusto nyo pang matuto ng more.